The moon looks like it has stopped. Night after night, across your entire life, it has held the same silent face, the same shadows, the same familiar pattern of light and darkness. It never turns away. It never surprises you. It feels fixed, almost frozen, like a painted object placed gently into the sky. But something about that stillness is deeply misleading, because the moon is spinning, and not just a little. It is spinning with perfect precision, in a way so exact, so finely tuned, that it hides its own motion completely. A cosmic illusion so flawless that for most of human history, we believed the moon didn't rotate at all. Which raises a quiet but unsettling question. If the moon is spinning, then why can we only ever see one side? And perhaps more strangely, what had to happen to make it spin this way? Tonight, we're going to follow that mystery all the way back through time, to a moment when the moon was not calm, not quiet, and not synchronized. A time when it spun wildly, unpredictably, like a glowing fragment of chaos orbiting a young Earth. Something changed. Something slowed it down. Not suddenly, but gradually, almost patiently, as if the universe itself reached out and gently took its spin away. Here on Velarin's Sleepy Space Mysteries, we explore questions like this: the quiet, hidden mechanics of the cosmos that shape everything we see, but rarely notice. In one of our previous journeys, we asked what would happen if the moon suddenly vanished. And the answer revealed just how deeply connected it is to life on Earth. But tonight's mystery is different, because the moon didn't disappear, transformed. And that transformation may be one of the most precise and delicate processes in the entire solar system. So before we drift deeper into this story, if you enjoy calm explorations of space like this, you can gently subscribe, leave a like, and turn on the bell so you don't miss future journeys. If you'd like to support the channel even more, you can consider becoming a member. And as always, I'd love to know, where in the world are you watching from tonight? Now, let's return to the question that started it all. If the moon is spinning, why does it look perfectly still? There is no sudden moment in the universe where motion simply disappears. Nothing stops without a reason. Nothing slows without something quietly taking energy away. And the moon did not lose its spin by accident. It was slowly, almost gently taken from it. Not by a collision, not by a single catastrophic event, but by something far more patient. Something invisible, constant, and impossible to resist. Gravity, but not the kind of gravity we usually imagine, the simple pull between two objects. This was a deeper kind of interaction, one that doesn't just pull but stretches, bends, and reshapes over time. To understand what happened to the moon's spin, you have to imagine a connection between Earth and the moon that is not rigid, not fixed, but elastic. As if the two were linked by an invisible field that could distort and respond to motion. When the moon first formed, it was spinning much faster than it does now. A full rotation may have taken only a few hours. Its surface was still hot, its interior soft, and its shape not perfectly solid. As it rotated, Earth's gravity pulled more strongly on the side facing it and slightly less on the far side. This difference created a stretching effect, forming what scientists call tidal bulges. These bulges were not large mountains or visible distortions, but subtle elongations in the moon's structure, enough to matter over long periods of time. Now here is where the quiet theft begins. Because the moon was spinning quickly, those bulges did not stay perfectly aligned with Earth. They lagged slightly behind. Imagine trying to keep a spinning object pointed at something while it turns too fast. It never quite lines up. That misalignment created a kind of internal strain. Earth's gravity was constantly trying to pull the bulges back into alignment, while the moon's rotation kept dragging them away. This tension produced friction deep inside the moon's interior. Not surface friction like rubbing your hands together, but internal friction within rock and molten material, where layers flexed, shifted, and resisted each other. And every time that happened, a tiny amount of rotational energy was converted into heat. At first, this effect was small, almost unnoticeable, but it never stopped. Rotation after rotation, orbit after orbit, the same process repeated. The moon spun, the bulges lagged, gravity pulled, friction resisted, energy was lost, slowly, steadily, relentlessly. This is what it means to say the moon's spin was stolen. Not taken in an instant, but drained away over millions of years. And as that energy left the moon's rotation, something else began to change. The spin slowed, not dramatically at first, but enough that the bulges started to fall closer into alignment with Earth. With less misalignment came less friction, but the process continued. Each cycle reducing the difference a little more, each moment bringing the moon closer to a new state. A state where the struggle between rotation and gravity would finally end. This is the key idea that often goes unnoticed. The moon was not forced into stillness. It was guided toward balance. The system itself was searching for the lowest energy configuration, the most stable arrangement possible. And that arrangement happens when the moon rotates at exactly the same rate that it orbits Earth, so that one side always faces its partner, and nothing needs to fight anymore. When that moment arrived, the bulges no longer lagged. They aligned perfectly with Earth's pull. The internal friction faded. The energy loss slowed to almost nothing. The theft was complete. The moon had given up its independent spin and entered a new kind of motion, one that hides rotation inside orbit so perfectly that from our perspective, it looks like no motion at all. But here is where the mystery deepens again. Because that energy did not simply vanish. It was not destroyed. In the universe, energy is never lost. It only changes form. So if the moon's rotation slowed, where did that energy go? The answer is subtle, but it connects everything in this system together. The energy that left the moon's spin was transferred into its orbit. As the moon slowed down, it also began to drift slightly farther away from Earth. Not quickly, not dramatically, but steadily, at a rate so small you would never notice it in a lifetime. And yet over millions and billions of years, that distance grows. Even now, the moon is still moving away, carried outward by the same process that once slowed its spin. Which means the story is not over. The force that took the moon's spin is still active today, still shaping the relationship between Earth and Moon, still adjusting their motion in ways too slow for us to feel. And if that process continues, what does it mean for the future of this system? What else might change, quietly, over time, while we continue to look up and see only stillness? If you could watch this process unfold in fast motion, the moon would not look calm or still at all. It would look like a system constantly adjusting itself, correcting tiny imbalances, always leaning toward a quieter state. The rotation would gradually slow, almost like a spinning top losing speed, not because something struck it, but because something invisible kept resisting it from within. And yet, unlike a top that eventually falls over, the moon never collapses into stillness. Instead, it reaches a different kind of motion entirely, one where spinning and orbiting become indistinguishable from each other. This is the strange equilibrium that hides in plain sight every night. But to really feel how precise this balance is, it helps to imagine standing somewhere far beyond Earth, watching the Earth and Moon together as a system rather than as separate objects. From that distant perspective, the Moon is clearly rotating. You would see it turn once during every orbit. There is no illusion there. The illusion only exists from where we are, standing on Earth, locked into the same frame of reference as the Moon's facing side. And that is what makes this phenomenon so quietly deceptive. The Moon has not stopped spinning. It has synchronized its spin so perfectly with its orbit that its motion cancels itself out from our point of view. This perfect matching is what scientists call synchronous rotation, but even that phrase feels too mechanical for what is really happening. Because underneath that synchronization is a long history of energy exchange, a negotiation between Earth and Moon that lasted millions of years. And that negotiation has not ended. Even now, the Earth is still involved in this exchange. In fact, while the Moon lost its spin long ago, Earth is still slowly giving some of its own away. This is where the story becomes even more connected. Because the same tidal forces that once acted inside the Moon are now acting inside Earth, but in a different form. Instead of solid rock flexing under stress, it is our oceans that respond. As the Moon's gravity pulls on Earth, it creates tidal bulges in the water, raising the ocean slightly on the side facing the Moon and on the opposite side as well. But Earth rotates much faster than the Moon orbits, which means these ocean bulges are not perfectly aligned with the Moon. They are dragged slightly ahead. And just like the misaligned bulges inside the Moon long ago, this creates a constant gravitational interaction. The Moon pulls back on those bulges, trying to realign them, and in doing so, it extracts a tiny amount of energy from Earth's rotation. This is incredibly subtle, so small that you would never feel it. But it is measurable. Earth's rotation is slowing down very gradually, making our days just a tiny bit longer over immense stretches of time. And that lost rotational energy does not disappear either. It is transferred outward into the Moon's orbit, pushing it farther away. So while the Moon's spin was once slowed by Earth, now Earth itself is being slowed by the Moon. The roles have shifted, but the process continues. This is why the phrase, "the Moon's spin was stolen," is only part of the truth. Because in reality, nothing was stolen in isolation. Energy moved through the system, from one form to another, from one body to another, always seeking balance. The Moon lost its independent rotation, but gained a stable orbit. Earth loses a tiny fraction of its spin, but the moon gains distance. It is a continuous exchange, a quiet conversation written in motion rather than words. And this conversation has a direction. It always moves toward a state where both bodies share the same rhythm. If given enough time, Earth itself would eventually become tidally locked to the moon, just as the moon is locked to Earth now. One side of Earth would always face the moon, and the moon would hang motionless in that sky, never rising, never setting. But that future lies billions of years ahead, far beyond anything we will ever experience. Still, the possibility reveals something important. Tidal locking is not a rare accident. It is the natural outcome of gravitational systems that are allowed to evolve long enough. It is what happens when motion is slowly refined, when excess energy is gradually removed, when chaos gives way to order. And yet, even in this near-perfect balance, the system is not completely frozen. There are still tiny imperfections, small deviations that remind us the process is ongoing. The moon's orbit is not a perfect circle. It is slightly stretched, which means its speed changes as it moves closer to and farther from Earth. Its axis is slightly tilted. Its internal structure is not perfectly uniform. All of these small details create subtle variations in its motion, slight oscillations that we cannot easily see without careful observation. These are the faint echoes of the past, the remnants of a time when the moon's motion was not yet settled. And they hint at something deeper, something we have not fully explored yet. Because if the moon's spin was slowly taken away, and if that process left behind traces in its motion and structure, then the moon we see today is not just a quiet object in the sky. It is a record, a memory of everything that happened during that long transition from chaos to balance. Which means the surface of the moon, its shape, even the differences between its near side and far side, may all be telling us something about how that transformation unfolded. Something that cannot be seen just by looking at it casually. Something hidden in its history. And that leads us to the next question, one that takes us further back in time. Before the balance, before the synchronization, back to when the moon was still wild, still spinning freely, and still changing. What was the moon like before its spin was taken away? And how different was it from the quiet world we see tonight? To understand what the moon was before this quiet balance, you have to let go of the image you carry now. The pale, steady disk in the night sky. The calm, familiar face that never changes. None of that existed in the beginning. The early moon was not stable, not predictable, and certainly not silent. It was a world still shaped by heat, motion, and constant adjustment. A place where rotation and gravity were still competing with each other rather than cooperating. If you could travel back to that time and watch the moon shortly after its formation, you would not see a smooth gray surface. You would see something brighter, almost glowing, its surface still radiating heat from its violent birth. Its rotation would be fast enough that the landscape would shift noticeably over the course of hours, not weeks. The Earth in its sky would not hang still. It would rise and fall, drift and shift, moving in a way that feels almost impossible compared to what we know today. This is the version of the moon that existed before gravity began its long work of slowing it down. And that work did not happen evenly. It did not affect every part of the moon in the same way or at the same time. The process of tidal interaction is subtle, but it leaves behind fingerprints. As the moon's rotation slowed, the internal stresses caused by those shifting tidal bulges did more than just remove energy. They reshaped the moon from the inside out. Regions that experienced more stress would heat slightly more. Areas closer to alignment with Earth would behave differently than those further away. Over millions of years, these small differences accumulated, creating asymmetries that still exist today. This is where the story begins to connect to something you may have noticed without realizing its significance. The two sides of the moon are not the same. The side we see, the near side, is smoother in many regions, marked by large dark plains formed by ancient lava flows. The far side, the one hidden from us, is rougher, more heavily cratered, and noticeably different in texture. At first glance, this might seem like a coincidence or simply the result of random impacts. But when you look at it through the lens of tidal evolution, it begins to feel less random. Because during the period when the moon was slowing down, one side was already beginning to spend more time facing Earth than the other. Even before full synchronization, there would have been preferred orientations, moments when the same regions faced Earth more often than others. That slight bias could influence how heat moved inside the moon, how its crust cooled, and how easily magma could rise to the surface. Over time, this may have contributed to the differences we see today. The near side, facing Earth more frequently, may have retained heat differently, allowing volcanic activity to reshape its surface. The far side, more isolated, may have cooled faster, preserving a more ancient and rugged landscape. In this way, the process that stole the moon's spin also helped sculpt its appearance. It did not just change how the moon moves, it changed what the moon became. And this idea reveals something deeper about tidal locking. It is not just a mechanical adjustment of motion. It is a transformation that affects structure, temperature, and long-term evolution. The moon's current state is not just the result of where it is, but of how it got there. Every crater, every plane, every subtle difference between its hemispheres carries traces of that journey. And yet, even as the moon was changing, even as its rotation slowed and its internal structure adjusted, the process remained incredibly gradual. There was no moment where everything suddenly snapped into place. Instead, there was a long period of near synchronization, where the moon's rotation was close to matching its orbit, but not perfectly aligned. During that time, the same regions would drift slightly in and out of view from Earth. The sky from the moon would slowly change, with Earth moving less and less each cycle, until eventually it stopped drifting entirely and became fixed in place. That moment, when the drift ended, marked the completion of the transition. But even then, the system was not entirely rigid. It still allowed for tiny motions, small adjustments that continue to this day. And those subtle motions are important, because they remind us that the moon's stillness is not absolute. It is a balance maintained by continuous forces, not a permanent freeze. The moon did not become a statue. It became a participant in a perfectly tuned system. And that system, as stable as it appears, carries within it the memory of everything that came before. The rapid spin, the internal friction, the slow loss of energy, the gradual alignment. All of it is still encoded in the moon's structure and motion, which leads us to a realization that feels almost poetic. When you look at the moon, you are not just seeing what it is now. You are seeing the result of a long and patient process that transformed chaos into order. A process that did not erase the past, but preserved it in subtle ways. And if that is true, then there is something else we have to consider. If the moon's current stillness is the result of this delicate balance, then what would happen if that balance were disturbed? What if somehow the process reversed, even slightly? What if the moon, after billions of years of perfect synchronization, began to spin differently again? Would it return to chaos? Or would the same invisible forces simply guide it back into balance once more? If the moon's balance were ever disturbed, even slightly, it would not simply drift into chaos without resistance. The same quiet forces that once slowed its rotation would immediately begin working again, correcting, adjusting, guiding it back toward equilibrium. This is what makes tidal locking so powerful. It is not just a one-time event, but a self-correcting system. Any small deviation creates a response, a restoring effect that gently pulls everything back into alignment. You can think of it like a pendulum that has already come to rest. If you nudge it, it will move, but it will not keep swinging forever. Friction, subtle and persistent, will always bring it back to stillness. The moon exists in that kind of state, except instead of a pendulum in air, it is a world suspended in gravity, surrounded by invisible forces that never stop acting on it. Even now, the moon is not perfectly locked in the way we might imagine. Its motion is incredibly precise but not flawless. There are tiny variations, small oscillations that shift its orientation by fractions of a degree. These are not signs of instability, but of flexibility within the system. They allow the moon to absorb minor disturbances without breaking its overall balance. In a way, this flexibility is what protects the lock. A perfectly rigid system would be more vulnerable to disruption, but a slightly adaptive one can maintain stability over billions of years. This is why the moon can experience impacts, internal shifts, and gravitational influences from the sun, yet still remain locked to Earth. And yet, imagining the moon breaking free even temporarily reveals just how important this balance really is. If the moon began to rotate at a different rate than its orbit, the first changes would not be dramatic to the eye. At first, the familiar face of the moon would begin to shift slowly. Features we have never seen before would gradually rotate into view, while familiar ones would drift away. The night sky would become unfamiliar, subtly changing from one evening to the next. But beneath that visual change, deeper consequences would begin to unfold. The gravitational relationship between Earth and Moon would no longer be as stable as it is now. The tidal forces would shift, not in strength immediately, but in timing and distribution. Ocean tides on Earth, which currently follow a predictable rhythm, would begin to vary in ways that could ripple through climate systems over time. This is because the moon's current orientation helps maintain a consistent pattern of gravitational pull on Earth's oceans. It is not just the presence of the moon that matters, but the way it is oriented and how its mass is distributed relative to Earth. When that orientation changes, even slightly, it alters how energy moves through Earth's oceans and atmosphere. Over long periods, even small changes in these patterns can influence weather, ocean currents, and the delicate balance that supports life. The moon, in its stillness, is acting as a stabilizer, a quiet regulator that keeps certain systems on Earth within predictable limits. But perhaps the most profound effect would not be immediate at all. It would be gradual, unfolding over thousands or millions of years. Earth's axial tilt, the angle at which our planet leans as it orbits the sun, is partially stabilized by the moon's gravitational influence. Without that stabilizing effect, or with it altered, the tilt could begin to shift more dramatically over time. That would change how sunlight is distributed across the planet, affecting seasons, climate zones, and long-term environmental patterns. The moon's stillness, then, is not just a curiosity. It is part of a much larger system that helps maintain the conditions we depend on. And yet, even in this hypothetical disruption, the universe does not favor chaos for long. If the moon's rotation changed, the same tidal forces that once slowed it would begin working again. The bulges would reappear, misaligned with Earth's pull, creating friction once more. Energy would begin to drain from the new rotation, just as it did billions of years ago. Slowly, almost imperceptibly, the moon would be guided back towards synchronization. It might take millions of years, but the outcome would be the same. The system would return to balance because balance is the natural end point of these interactions. This reveals something quietly profound about the nature of motion in the universe. Stability is not the absence of movement. It is the result of movement being refined, shaped, and guided until it no longer creates conflict. The moon did not stop spinning because motion ended. It stopped changing because motion found harmony. And that harmony is maintained not by stillness, but by continuous, gentle correction. So when we imagine the moon spinning again, we are not imagining a permanent change. We are imagining a temporary disturbance in a system that has already proven its ability to restore itself. The forces involved are too persistent, too consistent, to allow lasting imbalance. Gravity does not forget. It does not weaken with time in this context. It continues endlessly shaping motion into patterns that can endure. And this brings us back to the deeper idea that has been quietly building beneath everything we've explored so far. The moon's spin was not simply taken. It was transformed, redistributed, and ultimately woven into a larger system of motion that includes both the moon and Earth. The loss of spin was not an ending, but a transition into something more stable, more connected, and more enduring. But if that is true, then one final question begins to emerge. Not about what was lost or what might happen if things changed, but about how something so precise could form in the first place. Because the more we understand this balance, the more it begins to feel almost too perfect, too exact, too finely tuned to be random at a glance. So how did this synchronization begin? Was it simply the inevitable result of physics playing out over time? Or does its precision hint at something even deeper about how the universe organizes itself? So when we step back and look at the moon again, not just as an object in the sky but as the result of a long, invisible process, something begins to shift in how we understand it. What once seemed like stillness now feels like the final note of a very long composition, one that began with chaos, passed through resistance, and settled into harmony. The moon did not simply arrive at this state. It was shaped into it, slowly and inevitably, by forces that never rushed and never stopped. And perhaps the most remarkable part of this story is not that the moon became tidally locked, but that it did so with such precision. The timing of its rotation and orbit did not just become similar. They became identical to a degree that creates the illusion of no motion at all. That level of synchronization suggests something deeper than coincidence. Not design in a conscious sense, but the natural tendency of physical systems to move toward states that require the least energy to maintain. This idea appears again and again throughout the universe. Systems evolve, interact, and exchange energy until they reach configurations that are stable over long periods of time. In those states, motion does not disappear, but it becomes efficient, balanced, and self-sustaining. The moon's synchronous rotation is one of the clearest examples of this principle. It is what happens when a system has had enough time to refine itself, to smooth out its irregularities, and to settle into a rhythm that can last for billions of years. And yet, even knowing this, it is hard not to feel a sense of quiet wonder at how exact this balance is. The moon orbits Earth in just the right amount of time. It rotates in exactly that same amount of time. It maintains that relationship despite subtle influences from the sun, from its own internal structure, and from the slow outward drift that continues even now. Everything holds together not rigidly, but with just enough flexibility to remain stable. And that flexibility is important because it reminds us that this is not a frozen system. It is alive with motion, just moving on timescales that are far beyond human perception. The moon still shifts slightly, still adjusts, it still participates in an ongoing exchange of energy with Earth. What we are seeing is not a finished process, but a mature one, a system that has reached a stage where change happens so slowly that it feels like permanence. But permanence in the universe is always relative. Given enough time, even this balance will continue to evolve. The moon will keep drifting away. Earth's rotation will keep slowing. The relationship between them will keep adjusting, always moving toward a deeper level of synchronization. And this leads us to a realization that quietly reframes the entire story. The moon's spin was never truly taken in a way that left it diminished. It was redistributed in a way that made the entire system more stable. What looks like a loss is actually a transformation. The moon gave up its independent rotation, but in doing so, it became part of a larger, more stable pattern of motion. It entered into a partnership with Earth, one where both bodies influence each other continuously, shaping each other's behavior over immense stretches of time. This is why the phrase "stolen spin" carries a kind of poetic truth, even if the physics behind it is more precise. Something was taken, yes, but it was taken by a process that also gave something back. stability, predictability, and a relationship that has endured for billions of years. And that relationship has consequences far beyond the moon itself. It reaches into the oceans of Earth, into the length of our days, into the stability of our planet's tilt, and into the conditions that allow life to exist as it does. The moon's stillness is not isolated. It is connected to everything around it. It is part of a chain of cause and effect that stretches from the early formation of the solar system all the way to the present moment. Which means that when we look up at the moon and see that unchanging face, we are not just seeing a quiet object. We are seeing the outcome of a process that shaped both the moon and the Earth together. And yet, even with all of this understanding, there is still a lingering sense of mystery. Because while we can explain how the moon's spin slowed and how it reached this state of synchronization, there is still something remarkable about how perfectly it all worked out. The size of the moon relative to Earth, its distance, its initial rotation, the timing of its formation, all of these factors had to align within a certain range for this balance to be achieved. Too different, and the outcome might have been something else entirely. The moon might never have locked, or it might have drifted away before the process could complete, or it might have settled into a different kind of resonance like other bodies in the solar system. But it didn't. It ended up here in this precise configuration, one that feels almost uniquely suited to create the sky we see and the conditions we experience. And that raises a final thought, one that gently bridges us into the next part of our journey. If the moon's current state is the result of such a long and delicate process, then what did it take to begin that process in the first place? What kind of event could set all of this into motion, creating a world that would eventually lose its spin, reshape its surface, and become the silent companion we know today? To answer that, we have to go back even further, back before the slowing, before the tidal forces, before the balance, back to a moment of violence so immense that it reshaped an entire planet and gave birth to the moon itself. A moment where nothing was stable, nothing was synchronized, and everything was still in motion. If you're still here, gently listening, let me know by typing a quiet 1 in the comments. Long before the moon became the calm, unchanging presence we know today, it was born in violence so extreme that it is difficult to truly imagine. There was no gentle beginning, no slow formation from quiet dust drifting together. Instead, the moon emerged from an event that reshaped an entire world. A collision so immense that it did not just alter Earth. It created something entirely new from its aftermath. If we rewind time far enough, back more than 4 billion years, the Earth itself looked nothing like it does now. Its surface was unstable, its crust still forming, its environment hostile and chaotic. And moving through that early solar system was another body, a massive object not unlike a small planet, traveling on a path that would intersect with Earth in a single devastating moment. When that impact happened, it released more energy than anything our planet has experienced since. Rock did not simply crack or break. It melted, it vaporized. Entire sections of Earth's outer layers were thrown into space, not as solid fragments, but as streams of glowing debris, superheated and chaotic, expanding outward into orbit. From that expanding cloud, something began to take shape. Not instantly, not cleanly, but gradually, as gravity pulled the debris back together. Countless fragments collided, merged, and settled into a growing mass. That mass would become the moon. But this early moon was nothing like the one we see now. It was not solid in the way we understand solid objects. Its surface was likely covered in a deep ocean of molten rock, glowing with heat, constantly shifting and reforming. Its shape was still adjusting, its internal structure unstable, and its motion anything but calm. It spun rapidly, far faster than it does today, carrying with it the energy of its violent origin. In those early moments, rotation was not something subtle. It was a defining feature of the moon's existence. Its surface moved quickly, its orientation constantly changing, its relationship with Earth still developing. And Earth itself was not unaffected. The two bodies were much closer together than they are now, their gravitational interaction far stronger, their influence on each other more intense. The tides between them were not the gentle ocean movements we know today, but powerful deformations that affected both bodies, stretching, pulling, and reshaping them continuously. This early phase was a time of instability, but also of possibility, because it was during this period that the conditions were set for everything that followed. The moon's rapid spin, its molten interior, its close proximity to Earth, all of these factors determined how the tidal forces would act, how energy would be exchanged, and how the long process of synchronization would begin. It is important to understand that the moon did not start in balance. It started in excess. Excess energy, excess motion, excess heat. And the universe, through the quiet persistence of physical laws, began to reduce that excess over time. The same tidal forces we explored earlier were already at work, even in this chaotic stage. But their effects were stronger, more intense, because the moon was softer, more flexible, more capable of being deformed. Each rotation caused internal movement, each gravitational pull created stress, and each cycle converted a little more of that initial energy into heat. As the moon gradually cooled, its outer layers began to solidify. A crust formed, thin at first, then slowly thickening. But the cooling was not uniform. Some regions retained heat longer, others cooled faster. This uneven process contributed to the asymmetries that would later define the moon's surface. At the same time, the moon's rotation was already beginning to slow. Not dramatically at first, but enough to begin the long transition towards synchronization. If you could observe the moon during this period, you would see a world in motion, but also a world in transition. The spin would still be rapid, but slightly less than before. Its surface would still glow, but with patches beginning to darken as the crust solidified. Its orbit around Earth would still be close and fast, but gradually expanding as energy shifted from rotation into orbital motion. And through all of this, one thing remained constant: the influence of Earth. Always pulling, always shaping, always guiding the moon toward a future state that neither body had yet reached. This is what makes the origin of the moon so deeply connected to its current behavior. The same event that gave it its initial spin also set the stage for that spin to be taken away. The violence of its birth created the conditions for its eventual stillness. Without that immense collision, without that excess energy, the moon might never have entered the kind of tidal interaction that leads to locking. It might have remained a different kind of world entirely, spinning freely, evolving along another path. So when we look at the moon now, calm and unchanging, we are seeing the final chapter of a story that began in chaos. A story where energy was not only created, but gradually transformed. Where motion was not only present, but slowly refined. And where a world that once spun wildly was guided, step by step, into perfect balance. But this raises another question, one that takes us deeper into that early period. Because if the moon began as a molten, rapidly spinning world, and if tidal forces were already acting on it, how quickly did that transformation begin? Was the slowing immediate, or did it take vast stretches of time before the first signs of synchronization appeared? And more importantly, what traces of that early chaos are still visible on the moon today, hidden in its surface, waiting to be understood? The slowing did not begin with a single moment you could point to, no clear instant where the moon suddenly started losing its spin. Instead, it began almost immediately after its formation, quietly embedded within the same forces that were already shaping its orbit and structure. From the very beginning, the moon existed inside Earth's gravitational influence, and that influence was never passive. It was active, persistent, and deeply involved in everything the moon became. In those early millions of years, when the moon was still hot and partially molten, it was far more responsive to these forces than it is today. Its interior was softer, more flexible, more capable of being stretched and reshaped. This made the tidal effects not only stronger, but more efficient at removing energy from its rotation. If you imagine the young moon as something not fully solid, but more like a slowly moving, glowing mass, then each gravitational pull from Earth would have caused subtle deformations throughout its body. These deformations were not static. They shifted as the moon rotated, creating a constant cycle of stress and release. And within that cycle, energy was continuously being converted into heat. This is what made the early phase of tidal interaction so powerful. The moon was not resisting the process strongly. It was yielding to it, allowing the forces to act deeply within its structure. As a result, the rate at which its spin slowed during this period was likely much faster than in later stages. But even with that increased efficiency, the process still unfolded over immense spans of time. We are not talking about thousands or even millions of years in isolation, but tens of millions, perhaps longer, before the moon's rotation slowed enough to approach synchronization. This gradual pace is important because it allowed the moon to evolve alongside the process. Its crust thickened, its internal layers differentiated, and its overall structure became more rigid. As it cooled, the same tidal forces that once acted strongly began to lose some of their influence. The moon became less deformable, more resistant to internal movement, and therefore less efficient at converting rotational energy into heat. This created a kind of transition within the process itself. In the beginning, the slowing was relatively rapid, driven by a soft, flexible interior. Later, it became slower and more delicate, requiring far longer periods to make smaller adjustments. The moon was, in a sense, hardening into its final state, both physically and dynamically. And during this long transition, something subtle but important was happening. The moon was beginning to spend more time in certain orientations relative to Earth. Not perfectly fixed yet, but increasingly biased. There would have been periods where the same hemisphere faced Earth for longer durations before drifting away again. These moments of partial alignment were like previews of the final state, hints of the balance that the system was moving toward. Over time, these partial alignments became more stable, more frequent, until eventually the drift between rotation and orbit became so small that it effectively disappeared. But before that final synchronization, the moon existed in a kind of intermediate state, not fully free, not fully locked. And it is within this intermediate phase that many of the moon's lasting features were likely shaped. Because during this time, the distribution of heat, stress, and internal movement was not uniform. Some regions experienced more tidal flexing than others. Some areas remained warmer for longer periods. These differences influenced how the crust formed, how volcanic activity occurred, and how the surface evolved. This is where the moon's visible asymmetry begins to feel less like coincidence and more like consequence. The near side, which would eventually face Earth permanently, may have experienced slightly different conditions during this transitional phase. It may have retained heat longer, allowing magma to rise and create the dark plains we see today. The far side, less exposed to these effects, may have cooled more quickly, preserving a thicker crust and a more heavily cratered surface. These differences were not created in a single moment. They emerged gradually, shaped by the same forces that were slowing the moon's rotation. And as the moon moved closer to full synchronization, another shift occurred. The internal friction that once generated significant heat began to fade. With less misalignment between the tidal bulges and Earth's pull, there was less resistance, less internal movement, and therefore less energy being converted. The moon's interior cooled further, its structure stabilized, and the process approached completion. When the rotation period finally matched the orbital period, the system reached a point where the forces balanced out. The bulges aligned, the torque diminished, and the long era of significant energy loss came to an end. But even at that moment, the story did not truly stop, because the moon did not become perfectly motionless. Instead, it entered a state where its motion became almost perfectly coordinated with its orbit. A state where the same face remained directed toward Earth, not because it could not move, but because any attempt to move differently would be gently corrected. This is the essence of tidal locking. Not a rigid freeze, but a dynamic balance maintained by continuous interaction. And yet, the moon still carries the memory of everything that happened before that balance was achieved. Its surface, its structure, even its slight imperfections in motion all point back to that earlier time. A time when it spun faster, when it was hotter, when it was still finding its place in the system. Which brings us to an even deeper layer of the story. Because if the moon's surface preserves traces of its past, then those traces might reveal more than just the fact that it once spun freely. They might tell us how uneven that process was, how different regions evolved under different conditions, and how the hidden side of the moon came to be so different from the side we see. And that hidden side may hold some of the clearest evidence of the moon's ancient, chaotic history. The hidden side of the moon is not just a place we cannot see. It is a place that remembers differently. For most of human history, we imagine the moon as symmetrical, as if the side facing away from us must mirror the one we know so well. It felt natural to assume that what we could not see would be familiar, just reversed, just out of view. But when the far side was finally revealed, it told a completely different story. A story that does not match the calm, smooth face we recognize, but instead points back to a time when the moon was still being shaped by uneven forces, by imbalances that never fully disappeared. If you could stand on that far side, the first thing you would notice is how rugged it feels. The surface is heavily cratered, layered with impacts that have remained almost untouched for billions of years. There are fewer of the dark, smooth plains that define the near side. Instead, the terrain feels older, more ancient, as if it has preserved a deeper memory of the moon's earliest history. And that difference is not random. It is connected to the same process that slowed the moon's spin and guided it into its locked state. During the long transition toward synchronization, the moon was not experiencing tidal forces evenly across its surface. The side that faced Earth more often, even before full locking, was influenced differently than the side that did not. That near side, exposed more directly to Earth's gravitational pull, may have experienced slightly greater internal heating during key periods of its evolution. Not enough to reshape the entire moon instantly, but enough to influence how heat was distributed over time. And heat in a young planetary body changes everything. It determines how easily material can flow, how magma rises, how the crust forms and reforms. This is why the near side of the moon appears smoother in many regions. Those vast, dark plains are the result of ancient volcanic activity, where molten material once rose from below and spread across the surface before cooling. For that to happen, the crust in those areas had to be thinner, more easily broken, more willing to allow material to pass through. And that condition may have been influenced by the way tidal forces acted during the moon's early history. The far side, by contrast, appears to have developed a thicker crust. It did not experience the same level of volcanic resurfacing, so its surface remained dominated by impacts, preserving a record that reaches further back in time. In this way, the moon's two faces are not just different in appearance. They are different in history. The near side tells the story of a world that remained active for longer, reshaped by internal processes that continued after its formation. The far side tells the story of a world that cooled more quickly, locking in its earliest features and preserving them almost unchanged. And both of these histories are connected to the same underlying process, the gradual loss of the moon's spin and the redistribution of its energy. What makes this even more fascinating is that these differences were not imposed from outside. They emerged from within the system itself. The moon did not need an external event to create this asymmetry. It only needed time, gravity, and the slow evolution of its own structure. The same forces that aligned its rotation also influenced how its interior cooled, how its crust formed, and how its surface evolved. Everything is connected, each part of the story influencing the next. And yet, Despite these differences, the moon remains one object, one continuous body. The boundary between its near side and far side is not a sharp division, but a gradual transition. There are regions where the characteristics blend, where the story becomes more complex. This reminds us that even in a system shaped by long-term forces, the outcomes are never perfectly uniform. There is always variation, always nuance, always small deviations from the simplest explanation. These nuances extend beyond the surface. Deep within the moon, there are still signs of its past motion. Subtle variations in density, slight offsets in mass distribution, and tiny irregularities in its rotation all hint at a history that was once far more dynamic. Even though the moon appears still, it carries within it the echoes of movement, the remnants of a time when it was not yet settled. And those echoes are not just scientific details. They are clues, pieces of a larger puzzle that help us understand how the moon became what it is today. When we look at the moon now, it is easy to think of it as simple. A quiet object, unchanged, predictable. But the more closely we examine it, the more we realize that its stillness is layered over a deeply complex past. A past shaped by imbalance, by gradual correction, by forces that acted differently in different places over long periods of time. The moon did not become uniform. It became balanced, and that balance allowed its differences to remain visible, preserved rather than erased. And this brings us to an important realization. The moon's current state is not just the result of one process, but of many processes interacting over time. Its rotation slowed, its interior cooled, its surface evolved, and its orbit expanded. Each of these changes influenced the others, creating a system where nothing happened in isolation. The loss of spin was not a single event. It was part of a larger transformation that affected every aspect of the moon's existence. But even with all of this, there is still one piece of the story that feels incomplete. Because while we understand how the moon changed, we have not yet fully explored what that change means for us here on Earth. The moon's evolution did not happen in isolation. It happened in partnership with Earth, and that partnership continues to shape our planet even now. The tides, the stability of our axis, the rhythm of our days, all of these are connected to the moon's journey. So if the moon had never slowed, if it had remained a rapidly spinning world, how different would Earth be today? What would our oceans look like? Our climate, our nights, and more importantly, how much of what we take for granted depends on that quiet, nearly invisible balance that was achieved so long ago. If the moon had never slowed, if it had remained a rapidly spinning world, the Earth we know today would feel subtly, but profoundly different. Not in a way that would be obvious in a single day or even a single lifetime, but in ways that would reshape patterns so deeply woven into our planet that we rarely question them. The most immediate difference would begin with the tides, because the tides are not just the result of the moon's presence, but of its consistency. Right now, the moon pulls on Earth's oceans in a rhythm that is predictable, steady, and deeply synchronized with its orbit. But if the moon were spinning freely, that rhythm would become less stable. The gravitational pull would still exist, but its distribution would shift slightly as the moon's mass rotated relative to Earth. Over time, this would introduce irregularities into tidal patterns, small at first, but capable of compounding into larger variations across long periods. These changes would ripple outward into ocean currents, because tides are not isolated movements of water. They are part of a larger system that circulates heat around the planet, distributing energy from equatorial regions toward the poles. If the timing and structure of tides became less consistent, those currents could shift in subtle ways, altering how heat moves through the oceans. This would not necessarily make Earth uninhabitable, but it would make its climate less stable, less predictable, more prone to variation. Seasons might feel different over geological timescales, not because of a single dramatic change, but because of countless small adjustments accumulating over time. But the influence of the moon goes even deeper than the oceans. It extends into the very orientation of our planet in space. Earth's axial tilt, the angle at which it leans as it orbits the sun, is one of the key factors that create our seasons. That tilt is not fixed. It can change over time due to gravitational influences from other bodies. The moon plays a stabilizing role in this process, acting as a kind of anchor that limits how much Earth's tilt can vary. Without that stabilizing influence, or with it weakened by a different rotational relationship, Earth's tilt could shift more dramatically over long periods. This would lead to more extreme climate cycles, with regions experiencing greater swings between warm and cold conditions. Imagine a world where the poles tilt more sharply toward the sun at certain times, receiving far more energy than they do now, then gradually shifting away again. Ice sheets could grow and retreat more dramatically. Deserts could expand or contract in ways that are harder to predict. The balance we currently experience, where seasons follow a relatively stable pattern, might become more chaotic, more variable, less reliable over deep time. And all of this connects back to the moon's motion, or more precisely, to the way that motion has been stabilized through tidal locking. There is also a quieter, more subtle effect that is easy to overlook: the length of Earth's day. Right now, our planet rotates once every 24 hours, a rhythm so familiar that it feels fundamental. But that rotation is not constant. It is slowly changing, influenced in part by the same tidal interactions that once slowed the moon. If the moon had remained freely spinning, the exchange of energy between Earth and moon might have unfolded differently, leading to a different rate of change in Earth's rotation. Days might have lengthened or shortened along a different path, creating a different tempo for life to evolve within. This is where the story becomes less about the moon alone and more about the relationship between Earth and moon as a system. The moon's current state is not just a result of its own evolution. It is part of a shared history, a mutual adjustment that has shaped both bodies over billions of years. The slowing of the moon's spin, the gradual outward drift of its orbit, the subtle slowing of Earth's rotation, all of these are connected, each influencing the others in a continuous exchange. And this exchange is still happening. Even now, as you sit beneath the night sky, the process continues at a pace too slow to notice. The moon is still moving away, fraction by fraction, each year adding a tiny bit of distance between it and Earth. Earth's rotation is still slowing, just slightly, stretching the length of our days by an almost imperceptible amount. The system is not static. It is evolving, always moving toward a deeper equilibrium, even if that equilibrium lies far in the future. But what makes this so remarkable is how stable the system has already become. Despite all of this ongoing change, the relationship between Earth and Moon has remained consistent enough to support the development of life, the stability of climate, and the predictability of natural cycles. The Moon's stillness, its locked face, is part of that stability. It is not just a visual feature. It is a structural component of the system that keeps certain variables within a narrow range. And yet, when we look at the Moon, we do not see any of this complexity. We see a quiet surface, a familiar pattern, a steady presence that feels unchanging. The deeper story is hidden, embedded in motion that unfolds too slowly for us to perceive directly. It requires us to think across vast stretches of time, to imagine processes that take millions or billions of years to complete. This is what makes the Moon's story so quietly profound. It is not dramatic in the way we usually think of cosmic events. There are no explosions now, no visible transformations, no sudden shifts. Instead, there is a long, continuous process of adjustment, refinement, and balance. A process that began in violence, passed through instability, and settled into a state that appears almost perfectly calm. And as we move closer to the final part of this journey, one last idea begins to take shape. Because everything we have explored so far points toward a deeper pattern, one that extends beyond the Moon itself. Tidal locking is not unique. It happens elsewhere in the universe, shaping other moons, other planets, other systems, which means the Moon's stillness is not an isolated phenomenon. It is part of a larger story, one that connects our world to countless others, all shaped by the same quiet forces, all moving toward their own versions of balance. But why does the universe favor this outcome so consistently? Why does it seem to guide so many worlds into this same kind of synchronized motion? And what does that reveal about the nature of the cosmos itself? When we step back even further, beyond the details of the Moon's surface and the slow fading of its spin, a larger pattern begins to reveal itself, one that is not limited to Earth and its companion, but extends quietly across the entire solar system and far beyond it, repeating again and again wherever gravity is given enough time to work. The Moon is not the only world that has surrendered its spin to this process. It is simply one of the most familiar examples, placed close enough for us to observe and wonder about. Around other planets, the same story unfolds in different forms, with different timings, but guided by the same underlying principles. Moons orbiting giant planets, distant icy bodies circling in the outer reaches, even entire pairs of worlds locked together in mutual stillness, all following the same slow path toward balance. This repetition is not coincidence. It is the natural outcome of how energy behaves in gravitational systems, always flowing, always redistributing, always moving toward configurations that require the least effort to maintain. What makes the Moon's story feel so special is not that it is unique, but that we are close enough to witness the result in such detail, to see the final state of a process that usually remains abstract or distant. When you look at the Moon, you are seeing what happens when time is allowed to run long enough for motion to settle, for excess energy to fade, for competing forces to resolve into harmony. It is a completed example, or at least as close to completion as anything in the universe ever truly is. And yet, even as it represents this final state, it still carries the marks of everything that came before: the rapid spin, the uneven cooling, the gradual alignment, all preserved in subtle ways that only become visible when we look closely enough. This is why the moon feels both simple and complex at the same time. On the surface, it is one of the most predictable objects in the sky, rising and setting with quiet regularity, showing the same face, changing only in phase as sunlight moves across it. But beneath that simplicity lies a history of transformation that is anything but simple, a sequence of changes that required precise conditions, immense time, and the constant influence of gravity acting without pause. And that duality, the calm exterior and the dynamic past, is what gives the moon its quiet depth. It also invites a shift in perspective, because once you understand that the moon's stillness is not a lack of motion but the result of perfectly balanced motion, you begin to see other systems differently as well. Stability is no longer something static or lifeless. It becomes something active, something maintained through continuous interaction. The moon is not frozen. It is participating in an ongoing relationship with Earth, one that adjusts itself constantly, even if those adjustments are too small and too slow for us to notice in everyday life. And this brings us back to the idea that has been quietly threading through this entire journey. The moon's spin was not simply lost. It was transformed, redistributed into its orbit, into Earth's tides, into the gradual slowing of our planet's rotation. The energy is still here, still part of the system, still shaping the future even now. Nothing disappeared. It only changed form, becoming part of a larger pattern that connects both worlds together. In that sense, the moon's stillness is not an ending. It is a transition point, a phase in a much longer evolution that continues to unfold. The distance between Earth and Moon is still increasing, slowly but steadily. The length of our days is still changing, almost imperceptibly. The system is still moving, still adjusting, still guided by the same forces that shaped it from the beginning. And if we extend our imagination far enough into the future, we can see where this path leads, toward an even deeper level of synchronization, where Earth itself may one day share the same kind of locked relationship with the moon. But that future is so distant that it almost feels irrelevant, existing on a timescale far beyond human experience. What matters more, perhaps, is the present moment, the fact that we exist within this delicate balance, benefiting from the stability it provides without ever needing to notice it. The tides rise and fall. The seasons follow their familiar patterns. The moon hangs steady in the sky, offering a sense of continuity that feels almost comforting. And yet, now you know that behind that comfort lies a story of transformation, a story of motion gradually refined into harmony. The moon you see tonight is not just a quiet companion. It is the final expression of a process that began in violence, passed through instability, and settled into one of the most precise relationships in the cosmos. So the next time you look up and see that unchanging face, remember that it was not always this way. Remember that it once spun freely, that it once moved differently, that it was shaped by forces so patient and so persistent that they rewrote its motion over billions of years. And remember that even now, it is still moving, still adjusting, still part of a system that never truly stands still. If you've stayed with this journey all the way through, gently let me know by typing 2 in the comments. Just a quiet signal that you're still here, still listening, still drifting through this slow story of the moon. There is a quiet assumption we carry without realizing it. A feeling that the world around us is naturally stable, that the rhythms of day and night, the rise and fall of the oceans, the steady turning of the seasons are simply the way things are meant to be. But the deeper you look, the more you begin to understand that this stability is not guaranteed. It is maintained, carefully, continuously, and often by forces so subtle that they escape our attention entirely. And among those forces, the moon plays a role far more important than its gentle glow might suggest. Because the moon is not just orbiting Earth. It is holding something in place. Something delicate, something essential, something that has quietly shaped the conditions of life for billions of years. That something is balance. To understand this, you have to imagine Earth without the moon as it exists today. Not just the absence of light in the night sky, but the absence of a stabilizing presence, a gravitational partner that has been quietly regulating Earth's motion since the beginning. Without that influence, Earth would still spin, still orbit the sun, still experience the pull of other planets, but its behavior would be far less predictable. Its axis, the invisible line around which it rotates, would no longer be held in a relatively steady orientation. Instead, it would begin to wander more freely, shifting over long periods in ways that could dramatically alter how sunlight reaches the surface. This wandering would not happen quickly, but over millions of years, the effects would accumulate. The tilt of Earth could increase or decrease beyond its current range, leading to more extreme seasonal variations. In some periods, one hemisphere might receive far more sunlight than it does now, while the other remains in extended darkness. In other periods, the distribution could reverse. These changes would ripple through the climate system, affecting temperatures, weather patterns, and the distribution of ecosystems across the planet. Life would still exist, but it would have to adapt to a world that is less stable, less predictable, more prone to long-term shifts. The moon, in its current state, helps prevent that kind of instability. Its gravitational pull interacts with Earth's rotation in a way that dampens these variations, keeping the tilt within a relatively narrow range. It acts like a stabilizing weight, not stopping motion entirely, but limiting how far that motion can drift. And this stabilizing effect depends not just on the moon's presence, but on its relationship with Earth, on the precise way it orbits, and on the fact that it is tidally locked. Because that locked state ensures that the moon's mass is distributed in a consistent orientation relative to Earth, creating a steady, predictable influence rather than a shifting one. At the same time, the moon is influencing Earth in another way that is easier to see, but just as important. The tides. Every day, the oceans rise and fall in response to the moon's gravitational pull, creating a rhythm that is both powerful and gentle. These tides are not just movements of water. They are a mechanism for transferring energy, for mixing the oceans, for distributing heat, and for shaping coastal environments. They influence weather patterns, marine ecosystems, and even the long-term chemistry of the oceans. Without the moon's consistent influence, this system would still exist, but it would be weaker, less structured, less effective at maintaining the balance we depend on. And yet, what makes all of this possible is not simply the moon's presence, but the way its motion has been refined over time. The fact that it shows the same face to Earth, that its rotation and orbit are synchronized, contributes to the stability of its gravitational interaction. It ensures that the forces acting between Earth and Moon are not chaotic or rapidly changing, but steady and continuous. This is the hidden significance of tidal locking. It is not just a curiosity about how the moon looks. It is part of what makes the entire Earth-Moon system stable. But stability in the universe is never absolute. It is always relative, always maintained through ongoing processes. Even now, the system is still evolving. The moon continues to drift away, slowly increasing its distance from Earth. As it does, its gravitational influence weakens slightly. Earth's rotation continues to slow, lengthening the day by tiny increments over vast stretches of time. These changes are so gradual that they feel insignificant, but they are part of a larger trajectory, one that will continue long after we are gone. And this raises a quiet but powerful realization. The balance we experience now is not permanent. It is a moment in a long continuum, a phase in an ongoing evolution. The moon has already changed dramatically from its original state, and it will continue to change in the future. The stability we rely on is the result of conditions that have aligned in a particular way at this particular time. It is not guaranteed to last forever, but that does not make it fragile in a way that should cause concern. Instead, it makes it meaningful, because it reminds us that the conditions we experience are the result of a long chain of events, a sequence of interactions that had to unfold in just the right way to produce the world we know. The moon's stillness, its locked face, its steady presence in the sky, all of these are part of that chain. And yet, even knowing how important this balance is, it is difficult to fully grasp how much depends on it. Because the effects are not dramatic or immediate. They are subtle, distributed across systems, unfolding over time. It is only when we begin to imagine what would happen if that balance were disrupted that we start to see its true significance. What if the moon were not locked? What if its motion were different, less stable, less synchronized? How would that change the delicate equilibrium that has shaped Earth for so long? If the moon were not locked, if it rotated freely like it once did long ago, the first changes would not arrive as sudden disasters or dramatic shifts in the sky, but as subtle distortions in the patterns we rely on, small inconsistencies that slowly ripple outward into larger consequences. The familiar face of the moon would begin to change night after night, revealing new regions, hiding others, breaking the quiet visual consistency we have always known. But beyond that shifting appearance, something deeper would begin to drift. The gravitational interaction between Earth and Moon would no longer be as stable as it is now. Instead of a steady pull, there would be slight variations in how that force is applied, changing the timing and structure of tides in ways that would gradually reshape the behavior of the oceans. At first, these changes might seem almost unnoticeable, a slight irregularity in the rise and fall of water along coastlines, a variation so small that it blends into natural fluctuations. But over time, those irregularities would accumulate. Ocean currents, which depend on consistent tidal forces to help circulate heat and nutrients, could begin to shift. Some regions might experience stronger mixing, others weaker. Temperature gradients in the oceans could change subtly, influencing weather patterns across the planet. Storm systems might form differently, follow altered paths, or vary in intensity in ways that are difficult to predict. The climate would not collapse, but it would become less steady, more sensitive to small changes, more prone to long-term variability. And as these changes unfold in the oceans and atmosphere, another layer of instability would begin to emerge in Earth's orientation. Without the Moon's locked and consistent gravitational influence, the stabilizing effect on Earth's axial tilt would weaken. The axis would still be influenced by the Moon, but the interaction would be less uniform, less effective at dampening long-term variations. Over millions of years, this could allow the tilt to drift more freely, leading to more extreme cycles of change. Regions that are currently temperate might experience greater swings between warm and cold periods. Ice sheets could expand further during colder phases and retreat more dramatically during warmer ones. The boundaries between climate zones could shift more often, creating a world that is less predictable on geological timescales. This kind of instability does not announce itself in a single moment. It builds slowly, layer by layer, until the cumulative effect becomes significant. And that is what makes the Moon's current state so important. Its locked orientation provides a kind of consistency that prevents these variations from growing too large. It acts as a steady reference point, a constant partner in Earth's motion, helping to keep certain parameters within a range that supports long-term stability. Without that consistency, the system would still function, but it would be more sensitive, more prone to drifting away from equilibrium. There is also another consequence that is easy to overlook, one that unfolds not in the oceans or the climate, but in the rhythm of time itself. The interaction between Earth and Moon is gradually slowing Earth's rotation, stretching the length of our days by tiny increments. This process is directly linked to the way tidal forces operate, and it depends on the relationship between Earth's rotation and the Moon's orbit. If the Moon were spinning freely, the details of this interaction would change. The transfer of energy between Earth's rotation and the Moon's orbit might follow a different pattern, potentially altering the rate at which our days lengthen. Over immense stretches of time, this could lead to a different pace for the evolution of life, a different rhythm for biological and environmental cycles that are tied to the length of a day. All of these effects point to the same underlying truth. The Moon's stillness is not just a visual feature. It is part of a dynamic system that influences Earth in multiple interconnected ways. The tides, the climate, the rotation of the planet, the stability of its axis, all of these are linked directly or indirectly to the way the Moon moves. And that movement, refined into perfect synchronization, provides a level of consistency that allows these systems to remain balanced over long periods. But perhaps the most interesting aspect of this balance is how quietly it operates. There is no constant reminder of its importance, no dramatic signal that draws attention to it. It works in the background, shaping conditions in ways that are easy to take for granted. We see the tides, we experience the seasons, We live within the rhythm of day and night, but we rarely connect these experiences to the deeper mechanics that make them possible. The moon's locked motion is one of those hidden mechanisms, a piece of the system that operates so smoothly that it becomes almost invisible. And yet, when we imagine its absence, or even just a slight change in its behavior, the importance of that mechanism becomes clear. The balance we experience is not inevitable. It is the result of specific conditions, maintained over time by continuous interaction. The moon could have ended up in a different state. It could have remained freely spinning, or settled into a different kind of resonance, or drifted farther away before synchronization was complete. But it did not. It arrived at this particular configuration, one that supports a stable relationship with Earth. And that brings us to a deeper reflection. Because the more we understand this balance, the more it begins to feel like a narrow outcome among many possibilities. Not impossible, not miraculous, but specific. A result that depends on the interplay of mass, distance, timing, and energy exchange unfolding in just the right way. And that raises a quiet question, one that moves beyond the mechanics and into the nature of the universe itself. Why does this kind of balance emerge so often? Why do systems evolve toward synchronization, toward stability, toward configurations that seem almost designed for long-term harmony? The universe does not aim for balance in the way we might imagine, as if it were choosing harmony on purpose. It simply follows rules that, over time, lead to balance as the most efficient outcome. Energy moves, systems interact, and anything unstable gradually reshapes itself until it becomes stable enough to last. This is why tidal locking happens so often. Not because it is rare or special, but because given enough time, it becomes almost unavoidable. The moon is not an exception to this rule. It is a clear expression of it. And yet, even knowing this, there is something quietly astonishing about how perfectly this process has played out between Earth and the moon. Because this is not just any tidal lock. It is one that exists within a very narrow window of conditions. The moon is large enough to exert a strong influence on Earth, but not so large that it destabilizes the system. It is close enough to create meaningful tidal forces, but not so close that those forces become destructive. Its orbit is stable, its rotation synchronized, its influence consistent. All of these factors combine to create a relationship that is both dynamic and remarkably steady. And that steadiness is what allows life on Earth to experience long periods of environmental stability, something that is far from guaranteed elsewhere. If you look across the solar system, you will find many examples of tidal locking, but few that produce the same kind of balanced partnership. Some moons are locked so tightly to their planets that they experience extreme tidal heating, their interiors constantly flexing and generating energy, creating volcanic worlds that are anything but calm. Others are so distant that their interactions are weak, their influence barely noticeable beyond their immediate surroundings. The Earth-Moon system sits in a kind of middle ground, where the forces are strong enough to shape behavior, but gentle enough to maintain stability. And that middle ground is where something interesting happens. Because stability at this scale does not just affect motion. It affects the long-term evolution of environments. It creates conditions where changes happen slowly enough for complex systems to develop, adapt, and persist. On Earth, this has allowed oceans to form stable circulation patterns, climates to remain within certain ranges, and ecosystems to evolve over millions of years without being constantly reset by extreme shifts. The Moon, through its quiet influence, has been part of that process from the beginning. But there is another layer to this story, one that connects back to the idea of motion itself. Because what tidal locking really represents is not just stability, but efficiency. In a locked system, there is no wasted motion. The rotation and orbit are aligned in such a way that no additional energy is needed to maintain the configuration. There is no ongoing struggle between competing forces. Everything has settled into a pattern that can continue indefinitely, or at least until external influences change the conditions. This is why the Moon's current state can last for billions of years. It is not being actively held in place by a constant expenditure of energy. It is simply existing in a state where no further adjustment is necessary. And yet, even in this efficiency, there is still movement. The Moon continues to orbit. Earth continues to rotate. The system continues to evolve. But it does so in a way that is smooth, continuous, and self-consistent. This is what makes the Moon's stillness feel so complete. It is not just that we see the same face. It is that everything about its motion fits together in a way that leaves no visible tension, no obvious sign of change. This idea that systems evolve toward states where tension is minimized can be seen everywhere once you start looking for it. Planets settle into stable orbits. Stars form from collapsing clouds of gas and then spend billions of years in steady fusion. Even galaxies, over immense timescales, move toward configurations that are more stable than the chaotic beginnings from which they formed. The Moon's tidal locking is one small part of this larger pattern, a local example of a universal tendency. But what makes it meaningful to us is how directly we experience its effects. We do not need telescopes or distant probes to observe the outcome. We can see it with our own eyes. Every night the Moon is visible. We can feel its influence in the tides, in the subtle rhythms of the natural world, in the stability of the environment that surrounds us. It is part of our everyday experience, even if we rarely think about it in these terms. And perhaps that is why the question of the Moon's spin feels so compelling. Because it takes something familiar, something we have always accepted without question, and reveals a deeper layer of complexity beneath it. It turns a simple observation into a story that connects motion, energy, time, and the evolution of entire worlds. It shows us that even the most ordinary features of our environment can have extraordinary origins. As we move closer to the end of this journey, one final perspective begins to emerge. The Moon's stillness is not just about the past, about how it formed or how it changed. It is also about the present, about the role it continues to play, and about the future, about how this system will continue to evolve. Because even though the Moon appears perfectly balanced, the process is not truly finished. It is simply moving so slowly now that it feels complete. And that raises a final thought, one that brings everything together in a quiet, almost reflective way. If the moon's stillness is the result of motion refined over billions of years, if it is the natural end point of a long process of adjustment, then what we are really looking at when we see the moon is not just a celestial object, but a moment of equilibrium. A moment where everything has settled, at least for now, into a state that feels timeless. But nothing in the universe is truly timeless. Everything continues to move, to evolve, to change, even if that change is too slow for us to notice. So what does that mean for the future of the moon, for its relationship with Earth, and for the quiet balance that holds everything together? The future of the moon is not a sudden event waiting to happen, not a dramatic shift that will transform the night sky overnight, but a continuation of the same quiet process that has been unfolding since its beginning. The same forces that slowed its spin, that shaped its surface, that guided it into perfect synchronization are still at work, still moving energy through the system, still refining the relationship between Earth and Moon in ways so subtle that they escape notice. And yet, over vast stretches of time, these small changes accumulate into something meaningful. The moon is slowly moving away from Earth, increasing its distance by just a few centimeters each year, a rate so small it feels almost insignificant, but over millions of years it becomes a measurable shift, and over billions it transforms the system entirely. As the moon drifts outward, its gravitational influence weakens, not suddenly, but gradually, like a voice growing quieter with distance. The tides it raises on Earth will become slightly less pronounced. The exchange of energy between Earth's rotation and the moon's orbit will slow, and the rate at which our days lengthen will begin to change. None of this will be noticeable within human timescales, but it is part of a larger trajectory, one that moves the system toward an even deeper level of balance. If we follow this path far enough into the future, we arrive at a state that feels almost like a mirror of what we see now, but more complete. A state where not only the moon, but Earth itself becomes tidally locked. In that distant future, Earth would rotate at the same rate that the moon orbits it. One side of Earth would always face the moon, and from that side, the moon would hang motionless in the sky, never rising, never setting, a permanent fixture above a single hemisphere. On the opposite side, the moon would never be visible at all. It would be a world divided in a new way, shaped by a shared rhythm that has fully synchronized both bodies. This is the natural endpoint of the process we have been exploring, a final equilibrium where the exchange of energy reaches a state of balance so complete that no further change is needed. But reaching that state would take far longer than the current age of the universe. Long before that happens, other processes will intervene. The sun itself will evolve, expanding into a red giant, altering the conditions of the entire solar system, likely reshaping or even ending the Earth-Moon relationship as we know it. In that sense, the ultimate tidal lock between Earth and Moon may never fully complete. It exists as a theoretical destination, a direction the system is moving toward, even if it never arrives. And this highlights something important about the nature of balance in the universe. It is not always about reaching a final, permanent state. Sometimes it is about moving toward that state, about the process itself rather than the endpoint. The Earth-Moon system is stable not because it has stopped changing, but because it is changing slowly, predictably, and within limits that allow its structure to persist. The moon's stillness, then, is not the end of motion. It is a phase within an ongoing evolution, a moment where motion has been refined to the point where it feels almost invisible. This perspective changes how we think about the night sky. The moon is no longer just a constant presence, a fixed object that provides light in the darkness. It becomes a marker of time, a record of processes that unfold over billions of years. Its distance, its motion, its relationship with Earth all tell a story, not just of the past, but of the future as well. And that story is still being written, one small adjustment at a time. There is something quietly humbling in that realization. The idea that the sky we see is not static, not permanent, but part of a system that is slowly evolving, even if that evolution is too gradual for us to witness directly. It reminds us that stability is always temporary, always relative, always dependent on conditions that can change. And yet, within that impermanence, there is also a kind of enduring beauty, because the processes that create balance are themselves reliable, consistent, and universal. They operate everywhere, shaping systems across the cosmos in ways that are both predictable and profound. The moon's journey from a rapidly spinning, molten world to a calm, synchronized companion is one example of this broader pattern. It shows how complexity can give way to simplicity, how motion can be refined into harmony, how energy can be redistributed into forms that support long-term stability. And it does all of this without any need for intention or design, simply following the natural behavior of physical laws. As we approach the end of this journey, the question is no longer just about how the moon lost its spin or how it became locked to Earth. It becomes something quieter, more reflective. What does it mean that such a process exists at all? What does it mean that the universe, through simple rules applied over immense time, can create systems that feel so balanced, so stable, so perfectly aligned? Because when you look at the moon now, knowing everything that led to this moment, it is no longer just a familiar shape in the sky. It is the visible result of an invisible process, a process that is still unfolding, still guiding, still shaping the relationship between two worlds. And in that sense, the moon is not just a companion to Earth. It is a reminder that even the most stable things we see are part of something much larger, something still in motion, something that never truly stands still. And as we move into the final part of this story, there is only one thing left to do: to let that understanding settle, to step back from the details, and to see the moon not just as an object to be explained, but as a presence to be felt, a quiet reflection of the universe's ability to turn motion into harmony over time. And so, as everything gently comes together, the moon returns to what it has always seemed to be: quiet, steady, almost unchanging. But now that stillness feels different. It is no longer empty. It is full of history, full of motion that has been softened, slowed, and carefully shaped over billions of years. The face we see is not just a surface. It is the final expression of a long journey, one that began in fire and chaos and ended in balance so precise that it hides itself completely. And perhaps that is what makes the moon so calming to look at. Not just its soft light or its familiar shape, but the deep sense of resolution it carries, the feeling that something once turbulent has found its way into harmony. If you imagine time speeding up, the illusion would disappear. The moon would no longer seem still. You would see it turning, orbiting, drifting slowly away from Earth, its distance breathing outward inch by inch. You would see Earth's rotation gradually slowing, the length of each day stretching ever so slightly. You would see the entire system adjusting itself, always moving, always refining, never truly stopping. But we do not experience time that way. We live in moments, in days, in years, and within those scales, the moon appears constant, dependable, almost eternal. And yet, knowing what you know now, that constancy becomes something more meaningful. It is not permanence. It is balance. A balance that exists because motion has been shaped into a form that no longer conflicts with itself. The moon spins, but it spins in harmony with its orbit. Earth turns, but it turns while slowly sharing its energy with the moon. The tides rise and fall, carrying that interaction into the oceans, into the rhythms of the planet itself. Everything is connected. Everything is part of the same quiet exchange. There is something deeply comforting in that idea, that even in a universe filled with motion, change, and uncertainty, there are processes that lead toward stability, toward patterns that can last, toward relationships that endure. The moon is one of those relationships. It has been with Earth for billions of years, shaping its environment, stabilizing its motion, reflecting its light back into the darkness. And through all of that time, it has been slowly becoming what it is now, not through sudden events, but through continuous gentle change. When you look up at the moon tonight, you are not just seeing a distant object. You are seeing the result of gravity's patience. You are seeing what happens when energy is not lost, but transformed, when motion is not stopped, but refined. You are seeing a system that has reached a point where everything fits together so well that it feels effortless. And that effortlessness is an illusion, just like the stillness itself. Beneath it lies a story of forces interacting over unimaginable stretches of time, shaping a world into the quiet companion we recognize. And as your thoughts begin to slow, as the details soften and the story becomes more like a feeling than a sequence of ideas, you can return to that simple image. The moon, hanging in the sky, unchanged from one night to the next. A steady presence, a familiar light, a quiet reminder that not all motion needs to be seen to exist. Some motion becomes so balanced, so perfectly aligned, that it disappears into stillness. In that stillness, there is no urgency, no need for sudden change, only the gentle continuation of a process that has already found its rhythm. The moon will keep moving, Earth will keep turning, and the relationship between them will continue to evolve, slowly, quietly, almost invisibly. And for now, for this moment, everything is in balance. So as you rest, or drift, or simply listen to the quiet space around you, let that balance settle in your mind. The idea that even something as simple as the moon in the sky carries within it a story of transformation, a story of motion becoming harmony, and that perhaps, in its own way, the universe is always moving toward moments like this, moments where everything aligns, everything softens, and everything simply is. If you're still here, gently listening, let me know by typing a soft 3 in the comments.